Welcome to Homework 6.2, Factoring Trinomials. This section is fairly large in terms of the number of questions that you need to do in order to finish this homework. And that usually means there's a lot of short answer problems in this section, so don't get too nervous about the number of problems you have to do. They're very repetitive. There's nothing like the first 17 or so problems are the same thing over and over again with different numbers. So don't get nervous about that. Toward the end, there's some new concepts. And I might separate this chapter. In fact, I will separate this chapter into two sections, two separate videos, so that you don't have to deal with this entire chapter in one big gulp. All right, so let's take a look at what we want to do. In this section, they're talking about something fancy called trinomials. And the anything with a tri in front of it means three. And nomials are terms. Now remember we got what we did from last class. Here's the problem here. Pretend you don't see this part here. You don't need to see this part. Pretend you see this. This chapter deals with solving problems that look like this. Okay, that's what they're talking about. Where you have a square problem, a square term, 5x, an x term, and a number. So when you have a square, an x, and a number, they call that, and you have three terms, 1, 2, 3. Remember, pluses and minuses separate terms, and you got three of them there. They call it trinomial. Now, what did we do from last class? Well, what we did from last class is we said pluses and minuses bind terms together as one unit. Okay, that's one big unit there, and we want to be able to factor that unit. Now, the problem with those three terms is the stuff that we learned in section 6.1, the greatest common factor, it really doesn't apply because there's nothing, if I have three terms, there's nothing that's common to those three terms. I can't pull out an x because there's no x here. I can't pull out a number because the biggest number that's in front of the x squared is 1. Now remember, in this section, this will always be x squared or y squared or a squared. There'll always be a squared term with no number in front. That number in front would be the 1. So we're just going to concentrate on how do you solve trinomials with the number 1 in front of the squared term. There's got to be a way to do this, and I'm going to show you that way to do this. Now, if you remember back in Algebra 1, okay, and I'm sure you remember this, what you're going to remember is that anything that had a square, an x, and a number came from a term that looked like this, two terms that look like this, where the first term was x, because when you did this term, when you had two terms with numbers, pretend there was numbers there, plus 3, minus 5, whatever. You did a FOIL. Okay, remember in the back of your mind you did this thing called FOIL in order to do the multiplication of those two terms. The first terms would be x and x would generate the x squared. Now the last term, see what I generally do to fill out this pattern is I automatically say x and x in the front. When there's a number 1 in front, I say x and x because first terms, x times x, would give you the x squared. Then what I do is I look at the end, the last number. I see it's a minus 36. And a lot of people say it's 36. It's never just 36. It's the number in front. It's got to be included. The sign that's in front has to be included. So it's really minus 36. So what we want to do is come up with two numbers that multiply together to give you a minus 36. Okay, now the only way you can get a minus when you're multiplying two numbers is if one of them is plus and if one of them is minus. So basically what we're doing here is showing you like a little math puzzle. And this is what you have to get used to in this section 6.2. You're performing a math puzzle. See, and I said plus and minus because what comes over here are going to be numbers. And those two numbers multiplied together gives you a minus 36. But they have to FOIL out to give you the minus 5 in the middle. And so what I always tell my students is, think about it. Give me two numbers that multiply together to give you 36, but add or subtract to be 5. So what numbers can you come up with that multiply to be 36? Now, you need to know your times tables. And you need to know how to add or subtract negative numbers. So I'm just going to put the answer here, like so, and I'm going to prove to you that that's the correct answer, because look at this. 4 times minus 4 is negative 36. Yay, we got that. But this minus 5 is gotten when you do the FOIL. Let's do the FOIL. We'll do the FOIL right over here. We'll do the FOIL. What I mean by FOIL is that these two terms are the first terms. I say x times x is x squared. That's good. Outer terms right over here. These are the outer terms. And what I'm pointing to is minus 9, not all, minus 9 with the sign, times x is minus 9x. Now the inner terms are these two guys here, 4 times x. Those are the inner terms. And let me label this as the outer term. Plus 4x. And then the last, we know to be 4 times minus 9 is minus 36. Sorry for being, my mouse is moving here. It's not coming out too clean here. Let me just get rid of this smudge. Let's make a better 6. Let's make a better looking 6. Okay, that's a 6. That's a nice looking 6. Okay. Now, these are the 4 terms that I get, and this minus 5 is a combination of the two middle ones when you combine them together. And when you combine them together, because they're like terms, I get x squared minus 5x minus 36. And I know that's the answer. This FOIL job that we did over here, okay, is this answer. I know it's right, and they're even telling us that one of the terms is x plus 4, and the other term, if I plug it in there, would be x minus 9. X minus 9. Check your answer. Great job. All right. So we're going to do a whole bunch of these problems. This will make more sense. The key to doing these problems is to come up with two numbers that multiply to be the last number, but add or subtract to be the middle number, because the middle number is a combination of two things. Let's see if we can do the next one. Let's do every odd one. Okay, let's do every odd one like this. I would like to do every odd one. All right, we'll do every odd one like that. All right. Let's start off with a fresh sheet of paper. File. File. Close. Don't save. Let's start off with another new... There you go. Now, a new sheet of paper there. Virtual paper. Let's write down the problem. Okay, you're going to see this pattern a lot in math, where you have a square, an x, and a number. And whenever you see a square, an x, and a number, and you're asked to factor it, you automatically go with this template. 2 terms times 2 terms. Automatically the first term is going to be x times x to give you the x squared. That's a give me. Then what I do is I look at the end. I see a minus 10. The only way to get a minus number when you multiply two numbers is if one number is a plus and one number is a minus. And some people have asked me, why do I put the plus in front and why do I put the plus in front? It doesn't matter where you put the plus. I could put the plus in the back or in the minus. There's only one real answer. I put the plus because I'm a positive guy. Okay, I put it in front. That's the only reason. Now, here's the thing I'm going to ask you to do. Now, think about this. I need to generate the minus 10. I need to come up with two numbers that multiply to be minus 10. Could be 1 times 10. Could be 2 times 5. But those numbers have to multiply or have to add or subtract to be the middle number. I'm going to go with 5 and 2. 5 and 2 would subtract to be 3. Now here's the key here. I'm gonna do this by accident. I'm gonna make a mistake right there. Okay? You might think that's the correct answer. Okay? If I do a FOIL, x times x gives you the x squared, and the last term, 2 times minus 5 is minus 10. Nice. But the middle term will be wrong, because when I do a FOIL, remember there's an outer, that's the outer multiplication, and that's the inner multiplication. If I were to multiply this out, minus 5x plus 2x gives me a negative 3x. And that's wrong. That's no good, this problem right over here. There's only one real answer. So let's go back to a previous state of the problem. Let's go like this. X and x plus and minus. And I'm going to go with this. 5. Move the 5 here and the 2 here. And that, I think, will work for sure, because if I do a FOIL, you know if these are going to work because you wouldn't have gotten to Algebra 2 without knowing how to FOIL. Okay? And so if you do a FOIL, you may have forgotten FOIL. Don't forget it. But you're gonna get crazy with this FOIL because this entire Algebra 2 deals with FOIL in a big way. If I do the first terms, I get the x squared. If I do the outer terms, I get minus 2x. Inner terms is 5x. So minus 2x and 5x gives me the 3x. 5 times negative 2 is negative 10. I know that's right. I do know that's right, so let's move this over to the side. Oh, I do know, look at this. They give us one of the factors. See, these are the factors. Anything involved in multiplication is a factor. So x minus 2 is a factor, so the other factor must be correct, x plus 5. X plus 5. See, the first 3 or 4 problems, what they do is they try to help you out, giving you one of the factors to prove that you're getting this right. So that's done. Nice, nice, nice. Okay. Close this, don't save it. Let's start off with a nice fresh new canvas here. All right, here we go. We want to factor this, huh? Write the problem down. Okay, there's the problem. Now, first thing, understand that we have pluses and minuses bind terms as one big unit. Really, the first thing I should have asked is there anything I can factor using the stuff that we did in section 6.1? You know, is there a greatest common factor? And no, there isn't any. I mean, if there was the number 2 in front of the x squared, I'd factor out 2 because 2, 10, and 24, the greatest common factor would be 2. I could pull that out. But as long as there's a 1 here, there's not much you can do with the numbers. And you can't pull out an x because there's no x here. So you have to live with what you got here. So if you see this pattern, what you're going to do is automatically you're going to be a math machine. And you're going to say 2 terms times 2 terms. The first term is automatically x and x. Now I worry about the signs. I look at the signs up top here. Everything is positive. There's no need to have any negativity in the problem because everything is positive. So I'm going to go plus and plus. Okay? Plus and plus. Now, give me 2 numbers that multiply out to be 24, add or subtract to be 10. You got to know your times tables. You could say 1 times 24, 2 times 12, 3 times 8, 6 times 4. Now, all those numbers I just yelled out there multiply out to be 24, but only one of those pairs add to be 10, and I think you're going to remember 6 and 4. 6 times 4 is 24, and they would add to be 10. Add or subtract to be 10. So, and in this case, it doesn't really matter where you put the 6 and where you put the 4 because you got balance here. So I could put the 6 in front, I can put the 4 over here, and it doesn't matter what I put, whether I put the 6 in the back or the 4 in the front. That's the answer to that problem. Let's take a look at this guy. Let's put that in there. So I'm going to transfer that expression over to here. Now, when you do this, you've got to type it in exactly as you have it on your paper. X plus 4. Make sure you don't make any mistakes. Boom, we got that. Nice, 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 nice. Now, I'm going to skip this one because I see this too often. They put a plus and a minus in the back, and I'm going to just go on. They love plus and minus on here. Okay, let's do this problem. And then I'm going to go back. Okay, then I'm going to go back because there was a problem there that I want to talk about. X squared minus 11x plus 28. Okay, I like this. I like this a lot. So first thing, big bundle. And what you do in Algebra 2 is take these big bundles and rip them apart. Factor them into smaller bundles. This is a smaller bundle right over here. And that's what I do whenever I see the pattern square, x, and number. And then inside that bundle, the first term is automatically given an x and x. Right there. Now, what about the signs? I look at the 28. I see 28's positive. Now, there's two ways to see. Remember, there's going to be two numbers over here. There's going to be two numbers, and those numbers can be positive and negative. I think, I more than think, I know that it can't be positive. In order to get a positive 28, you can multiply two positive numbers, but that can't be the solution because I see negativity over here. Okay, if this were a plus, then I would say two numbers would be the correct. Two positive numbers would be correct. Two negative numbers also multiply out to be 28. Two negative numbers multiply out to be 28, so positive 28. So I'm going to stick with negative and negative. And because they would add, two negative numbers add to be negative. So now what I want to say is give me two numbers that multiply out to be 28, add or subtract to be 11. And if you know your times tables, and it doesn't matter where you put the 7 and 4. 7 and 4 would be the answer. There's no, I could have put the 4 in front and the 7 in the back. It don't matter because there's balance here. It's x minus and x minus. The only time it really makes a difference is if you had an x plus and an x minus. Then it makes a difference where you put those numbers. But I think if you do a foil, foil this out, you'll get the negative 11 in the middle. So I'm going to put that right in here and say x minus 7, x minus 4. Check my answer. Great job. Okay, let me go backwards. There was one problem I want to go into right over here. Okay, now you might think, okay, let's put that problem down. X squared plus 11x plus 29. And you say, okay, that's one big bundle. And I'm going to go with this pattern here. Okay. X, X. Everything is positive, so no reason for any negativity. X plus, X plus. You look at the 29. You ask yourself, is there two numbers that multiply out to be 29, add or subtract to be 11? The only numbers I can come up with to multiply out to be 29 is 1 and 29. That's it. There's no other combination of numbers that give you an 11, that give you a 29 when you multiply them. And 1 and 29 just does not add up or subtract to be 11. So not every problem can be done. This is a problem where it cannot be factored. Can't do it. Can't do it. And when you can't factor it, the answer is prime. Remember what prime is? Prime is a number that can't be factored. The number 1 and itself don't count. Okay, this cannot be factored. I'm going to check my answer, and I'm going to say a well done for that guy as well. Okay, so I hope you guys are getting this. Let's try number 10 and see. Oh, we got a couple of negatives. Okay, now this board is kind of cluttered, so let's get rid of that. File, new, okay, and you always have to copy your problems down like this. X squared. I like that they use x because it's easy to do this on my Paint program. 5x, maybe not so easy. Minus 36. Okay, one big bundle. Now, edit undo. Edit undo drawing. Okay, there you go. Now let's come over here. That's a better parenthesis. All right. First step. Is there anything I can pull out? Greatest common factor? There's no greatest common factor. No. So live with what you got here. X squared minus 5x minus 36. Let's make a better looking x. Minus, oh, let's undo. I've lost my mind. I lost my mind. What did I just do there? I'm just copying the problem. Edit, undo, undo. Let's do edit, undo. Okay. Sorry about that. I lost my mind. Let's come back here. Okay. What I meant to say is, I know the pattern of squared x's and numbers means I can break it down into two smaller bundles, where one bundle has an x in front, like so. I don't look at the middle so much as I then go look at the last number, and I see that last number is negative. And the only way to get a negative number is if one number is positive and one number is negative. Okay, that's the only way to get a negative number. I ask myself, give me two numbers that multiply out to be 36. Now, there's a whole bunch of numbers that multiply 36. 1 times 36, 2 times 18, 3 times 12, etc., etc. I'm going to go with 9 and 4. 9 and 4 would multiply out to be 36 and would subtract to be 5. So that's a candidate right there. Where do I put the 9? Where do I put the 4? I'm going to, because I see a negative there, I'm going to put the bigger number here and the 4 here. Now, if you don't believe me, you don't have any confidence in what I just said there, what I'm going to say is do a FOIL. Just do a FOIL. First terms are x times x, that's x squared. The last terms are guaranteed to be 4 and negative 9, that's negative 36. The outer, see, the minus 5 is complicated because it's a combination of two things. It's the outer and the inner. Okay, so negative 9x plus 5x is negative 5. I'm going with this guy. That's the correct answer right there. So I'm going to say x plus 4, x minus 9. Check your answer. Fantastic. Fantastic right there. Okay. What do you think this answer is by looking at it? Okay, let me see if we can try this out without using the paper. If there is an answer, it's going to be 2 terms times 2 terms. It's given that x is going to be the first terms. I look at the minus number, the negative 17. Negative 17 is multiple. Okay, what comes after the x are going to be numbers. Those numbers can be plus and minus. One of the numbers has to be plus and one of the numbers has to be negative because that's the only way you can get a negative number when you multiply. Now 17. Give me two numbers that multiply out to be 17, add or subtract to be 8, and you know what? There are no such numbers. Sorry. We did all this work for nothing. There's two. The best you can do is 1 and 17. That's the best you can do. That's the best you can do to get negative 17. And there's no way those numbers can add or subtract to be 8. And that's the only pattern you can have. So I'm going to say that's prime as well. Very good. Very, very good. So you have to start out assuming that there is an answer. And then if you find that there isn't, you go with the prime. Okay, halfway done with this guy. Well, you know what? I'm going to skip that one. Skip that one. I'm going to do this. I'm going to skip that one too. Okay, I'm going to go with this guy. I'm going to go with that one. Let's see. You know what's wrong with this problem here? 21 minus 10s plus s squared. Okay? And one of the reasons why you take math is to get your mind thinking logically and in patterns. Okay? People think, if you think in terms of a pattern that you've seen before, you tend to get the right answer because your mind gets thinking of the same pattern over and over again. This is not the same pattern as what we've seen. This is in the wrong order. Every problem we've seen so far had the square variable in front and the number in the back. The minus 10s is okay where it is. So it's okay for you to move terms around, but when you move terms around, it's always with the sign in front. So that s squared has got to go in front. No need to put the plus in the front. There's no need. The minus 10s is okay where it is. And this is a positive 21, so I'm going to put positive 21 over there. at the end, and now I'm happy. My brain now is happy because it sees the same pattern over and over and over again, and it's used to it. So I'm going to say if there is an answer, I'm going to go ahead and say, well, 2 terms times 2 terms, good. The first variable is an s. Now, it's not x because there's no variable. We get used to saying x, 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 but it's s, s. That looks like a 5, but that's really an s. What do you think the signs are? See, I start off my pattern with the variable, and now I worry about the sign. Well, I see a positive 21. The positive 21 here, but that generates a negative in the middle. I'm going to say double negatives. 2 negatives multiply out to be a positive. That's good, but they would add to be negative. Remember, the middle term is the combination, an addition of outer and inner when you do the FOIL. Now come up with 2 numbers that multiply out to be 21. I'm going to go with 7 and 3. They have to add or subtract to be 10 in the middle. 7 and 3 does the job, and it doesn't matter where you put the 7 and the 3. Because I could have put the 3 there and the 7 there, and it doesn't really matter. You'd still get the same FOIL job. So this is what struck me. I put the 7 in the front, so s minus 7. S minus 3. I'm going to go with, check my answer. Great job, and I'm very, very happy. So we went up to the 14. I know we skipped a few problems in between, but the problems in between are the same problems. So let's not get too nervous about the points that we skipped. They're the same exact problems. Let's try number 15. And you know what? I think what we're going to do is stop right there for this video. Yeah, this is what we're going to do, is stop right here for this video. So I'll make another video to finish up. I'll start at number 15 because this particular problem is a little bit more complicated. Not much, but it's a little bit more complicated because we have double variables, not just one variable, but 2 variables. And don't get nervous about it. I'm going to show you a way to solve this, but I'll do this in the next video. All right, you should be able to do the first 14 problems. Good luck.